Okay. Okay. So today we will discuss about the STP. Okay. Um, what is STP? Okay. STP it's a spanning tree protocol. Okay. Spanning tree protocol. I have to buy one pad. I think better that I can write with pen. Okay. So today is a spanning tree protocol. So what is spanning tree protocol and what it will do? So first, spanning tree protocol, it's a layer 2 protocol. Like we discussed, right? We have L2 protocols and L3 protocols. Yesterday we said like ARP is a layer 2 protocol. Similarly, STP, spanning tree protocol, it is also a layer 2 protocol. Okay. So what spanning tree protocol will do? Spanning tree protocol in an organization, when we have multiple layer 2 devices are connected, so there is a chance for a loop. So spanning tree protocol, it will eliminate the loops. Okay, how it will eliminate? So it will create a logical connections using the physical connections. So okay, so by that way it will do. So the it will avoid the loops. So that's why we need to use this spanning tree protocol, right? So and I'll give one example. Let's say let it be STP. For example, I'll give one scenario here. If there are two switches, okay, let's say switch A and switch B. So if I want to send any frame from switch B to switch A, so I have two ports. So if there is a computer, so here user is requesting, he is looking for a destination which is located at, which is connected at switch A. Okay. So what it will happen now? Here ARP, it is a broadcast message. Now requester will send a broadcast message. So now it will go to switch. So what switch will do? It will forward this frame to switch A. But now we have two ports, right? So if I broadcast same frame via this port 1 and port 2, then this switch will get confused. Like because we know, right, whenever frame is reaching the switch, what it will do, it will read the frame, like what is the source, okay, what is source MAC address, what is the destination MAC address, what is port, if any service, if and I like a header information, okay, or payload. So it will read this all source. So now if there is a frame is going, okay, this packet is going from B to A. So now two interfaces will broadcast this frame to here. Again, now what switch can do? Same MAC address now. So what will happen if a switch receives a same MAC address on different ports? Then it will create the MAC flapping. Okay, so it will create a MAC flapping. Okay, what will happen if it will create a MAC flapping? Then again port may go to like disable mode, and communication will not establish. So unnecessarily load will increase, right? So what we have to do, uh, if like a spanning tree, what it will do when two ports are active, okay? When two ports are active, what spanning tree protocol use? For example, it will use this interface 1, and this interface do what it will do. It will use this as a backup interface. Okay, unless this interface 1 is up, the communication will go from this client to switch A via port 1. But if this port 1 will goes down, then what spanning tree protocol will do, it will activate the port 2. So now this path is down for us. Now the another same again, we can send the communication via port 2. So what it is giving us, it is giving redundancy to us. It is giving redundancies to us. It is also giving backup for us. Okay, if this is down, for example, if we are it is only one interface we have, we do not have this another interface. If this one interface also goes down, then our connectivity between switch and B is gone. So we cannot reach from switch A to B and B to A, right? Now we understood, right, how spanning tree protocol will eliminate the loops and how it will keep the network up. And when there are two interfaces to same switch, so how it will keep one port as allowed and another port is blocked, right? For example, we can take one more scenario here, okay?
Yes, sir. Tunneling, right? Even tunneling also, like if one loop is down, then another loop is
Correct.
it will come out.
So now, so here, okay, here one system will connect, or one user is connected. Same one user will connect here. Same one user will connect. So user A and user B, then user C. For example, I am the user A, so I want to reach C. Okay. So what I will do, I will again send the our broadcast message, and I have port 1 and 2. What switch will do by default, except this port, it will broadcast that frame to port 1 and port 2. Okay. Okay, fine. We are going here and we will reach. And same packet will go and see. So again, MAC flop chances is there. That is one scenario. If second scenario, this none of the device don't know their destination. What we like in layer 2, we do not have any TTL expire time. For example, we discussed, right, when we discussed about the ping and trace route, it will go with a certain TTL value. For example, it will go with the TTL1, TTL2. If the TTL value is completed, then packet will expire. But in layer 2, there is no TTL expire. So for example, I'm trying to reach particular destination. So I'm sending a frame from A to from one C destination. Okay, what it will do? It will broadcast here. Okay, so again it will go, it will broadcast here. Same again, it will broadcast here. So, and if these three switches don't know my destination, then what it will do, it will keep on broadcast. Like we said, right? At during the initial communication. So it will broadcast message on all its ports. If it is connected to any multiple ports, it will broadcast that frame to multiple ports. Then what will happen? It will keep on broadcast like a circle. Then we have a chance to form a loop. If loop will form, our network will get collapsed, CPU load will increase, and devices will go down. Your whole network will go down, right? So what spanning tree will do now? Let me take here. What spanning tree will do here? For example, here is switch 1, switch 2, switch 3. Okay, 1, 2, 3. We'll connect. So to avoid this, now what switch will do? So first switch will find the best path for it. Okay. So after finding the best path, since we have two path 1 and path 2. So whatever STP feels or whatever STP prefers, that particular path it will allow and another path it will block, right? So at a time, either we can send a communication like this, okay? If we are sending communication like this, then this will be blocked. Else, if we are sending communication like this, like 1 to 3, then communication via 1 to 2 will be blocked. Okay, so this will use as a backup port. So until unless at a time one path will work, other path will be in block mode, or it will be like right, it is in blocking mode. So by this way, we can go send traffic via one route. Also same route we will receive the traffic. So there is no chance for the loop. So by this way, we can avoid the loops. Fine, till here we are good. Now we have switches again, like switch 1, switch 2, switch 3. This is fine. As of now, we are good. So we discussed that STP will avoid the loops. But first, how it will avoid the loops? Because it knows, right? Okay, I'm getting the proper update from here. I'm not getting the proper update from here. Someone is there to validate, or someone is there to review this all. So that's why what it will do in a spanning tree protocol, when there are multiple switches connected. So from these multiples, for example, let's say now we have a switch A and switch B and 1 minute, switch B and switch C. In our network now 3 switches are connected, right? But now how we will decide which is a superior or which is a supreme switch? So in spanning tree protocol, there is a method is there. Whichever switch having the lowest bridge ID, okay? Whichever switch having the lowest bridge ID, that will be elected as a root bridge, okay? Whichever having the lowest bridge ID, that will be elected as a root bridge. Fine. So how root bridge election will happen? In Cisco, not like all the switches, by default, it will have a 32,768. Same value, same default switch priority for the if you not changed anything manually, then the default priority is 32,768. Both at all these switches A, B, C, all these have same 32,768. Fine, till here fine. So first of all, we said, right, root bridge. So root bridge will be elected based on the lowest bridge ID. First, what is lowest bridge ID? So lowest bridge ID is a combination of priority plus MAC address. Okay, priority plus MAC address. And if your priority is same, by default, all switches will have same priority, 32,768. So if your priority is same, then the second verification step or second priority, it will decide based on the lowest MAC address, right? For example, now my system having 32,768. Switch C also having same. Switch A also having 32,768. So all switches priority is same now. Okay, now we have, let's say MAC address, we have A, B, C. So in this, A is the lowest MAC address. So what is our condition to form a root bridge? First, we can select lowest priority. Since our priority of these all switches is same, then we will consider the lowest MAC address. So A is the lowest MAC address, then 32,768 plus A. So this combination, so this priority plus MAC address, based on this, it will form a root bridge. So now our root bridge is switch A. So MAC address is a 6-byte value and priority is a 2-byte value. Okay. 6 plus 2 or 2 plus 2, it is a 8 bytes. So we discussed, right, each byte having 8 bits. So we have, yes, 8 bytes. So we have total 16 bits. 16 bits, then 2 power of 16. How much? So it will come around 65,536. 65,000. So 2 power 16 equals to 65,535. Sorry, 536. So when we will consider this as a range, if we start from 0, okay, so this is a 0 to 65,536. So this is our port range. So from this port range, we will use the priority. Okay, but if you will not change anything priority manually, the default priority is 32,768. So now we understood, right, in STP how root bridge will be formed. Fine. Now root bridge is corrected. Now root bridge is formed, right? Now, so how the switch C and B knows my switch A is a root bridge, correct? Because someone has to tell to switch B and switch C. So what it will do, so before forming root bridge, each switch, it will send their BPDUs to each other. Okay. So BPDU, it's a bridge protocol data unit. This is one of the important part. So BPDU, bridge protocol data unit. What it will do, it will transfer these STP messages, okay, or frames to each other. So now these switches can see their switch priority, their so their root bridge they can compare. For example, 32,768 plus B, 32,768C. So it will transfer these bridge IDs each other. So now all three switches compare it. Then they understood, right? Okay, this is having the lowest MAC address. Then switch A is the root bridge. So then they will decide as a non-root bridge. So once root bridge is formed, these non-root bridges will not send any BPDUs. So now this is the superior switch. So it will control this total network now to send. So it will decide. So either I want to select this path or I want to select this path, right? Now, for example, we have switch A. From switch A, we have connectivity towards switch B and switch C. If I want to reach switch C, I can go two ways. One is A to B directly. Another one is A to C, then C to B. Okay. So which is a shortest path now? Either this one is short or going to C again C to B, which is the shortest path. If I send a frame towards B via directly and via C, which one will go fast?
A to B.
Okay, now A to B. So what spanning tree protocol will do, it will keep this path is active or in forwarding mode, and this path it will keep in a blocking mode. Okay, in blocking mode, what will happen? Unless this path is active, so switch cannot send BPDUs or frames to this path. It only listens, but it cannot send and it cannot receive. So it will act as a backup path unless active path will goes down, right? So now there is physically to see we have two paths, but I said, right, STP will create a logical connections, and STP will form a logical connectivity. So it will like connectivity look like A to B and B to C, like this straight. So only this connectivity until unless this goes down. So okay, now frame will go like this, and I go via same. This is the path. Whether it if want to reach B, it will go B. If not, then it will go. If it want to reach C, then it will go to B. Then it will go to C. Okay, clear?
So I do have a question.
Yes.
So if from A to B, if it's the packet is traveling, and there is
Mhm.
also a way from A to reach B from A, C, and B, then if the packet drops at A to B, then what will be the reason? Like due to DOS attacks, or it will be like uh, any other reason? Like if this packet drops, then what about the other interface? Like
No, can you repeat the question again?
yes, sir. So my question is, if the packet is going to destination A, from A to B,
Okay, A to
right?
B.
A to B,
Mhm.
and there is also a path from to reach the destination B from
Mm.
A, C, and B, right? B
A
is the
C
destination.
B.
Yeah,
Okay,
A, C, B, right?
understood. Okay.
So yeah. So if the reason, what will be the reason behind to drop the dropping of packet, from A to B, from A to B, what will be
Though
the reason? Like due to DOS
okay,
attacks or any other reason? What will be the reason
anything.
to
Maybe
if the
your
yeah
physical, maybe your physical this interface may goes down, or your cable may goes down, or if due to sometimes what will happen if any conflict will happen, like for example any flapping will happen, then by that switch what it will do, it will send that port into error disable mode. So the once the interface is in error disable mode, it is like down only. So these are the multiple reasons to go a interface into down state. So during this situation it will make another path up, and it will travel through that another backup path. uh,
okay.
is
So
it clear?
what if the switches, like one of the switches, like is totally down? Then what will be the issue?
That is
What will be
also
the
fine
solution?
if complete
If the
switch goes
complete,
down.
yeah, yeah,
Okay, if for example this complete switch goes down, same again it will go via this backup path only. It won't definitely those are who connected to this switch will impact, but this total flow will not impact, because now for example this is down, our frame will go till here. If within certain response if we are not getting uh, a response, then it will block this port, and it will again it will send the traffic via like this frames.
yeah, yeah. I understand. But the thing is, if the complete switch goes off, like if A goes down completely, will
Okay,
the packet only travel through C to B, or how it's going to be end?
definitely if for example it will travel through C to B only, because for example you are saying this A is completely down,
Yeah, right,
because now we don't have a path towards this both the sides. Now only
right,
existing communication is this one only, C to B. So
right.
obviously they have to communicate via C to B only.
So what about A, the which the IP is connected, like the devices are connected to A. What about them?
Definitely
They gonna get error, right?
those will face the network problem.
Yeah, okay.
So those will face, but in real time what will happen, that's why until unless it is a end users in, like we have a networking like core layer, distribution layer, access layer. Except this access layer, everywhere we will have redundancy. For example, if I have a switch 1, similar way I'll configure one more switch 2 as well, right? So whatever the configuration in switch 1 will replicate in switch 2 as well. Now
Okay.
here in middle one more distribution switch is there. So here also again we have two switches. So switch 1, switch 2. Switch 1 will connect to 1 and 2. Switch 2 also will connect to 1 and 2. If switch
Okay.
1 goes down, then say since same configuration, will be available on 2. So it will take this path. In
So the devices which are connected to A, they cannot communicate with B and C, right?
except core, this access layer, remaining core layer, distribution layer will be fine, because core is heart of network. If this goes down, for example, I'll show you an example. Okay, how the real-time scenario, you have one data center here. Okay, you have one data center. Let's say, for example, you have SBI Bank. So your data center at one place. Usually we will have multiple data centers, because that also we will have. For example, if suddenly data center goes down, or some if in any state face power problems, since we know, right, these organizations were running with lakhs of crores, they won't depend on one data center. So they have multiple data center. But even though I will explain with one scenario, if we have one data center, it will, so data center, this is completely come in the core. Then the middle one will come in the distribution. It is like you can treat as a, if this is a data center, you can treat this as a head office. Then few of the applications also located in head office as well. Then branches will come. Okay, branches will come. So what will happen? SBI branch, for example, this is a data center in Bangalore. Okay, but we have multiple locations all over the states. For example, we have a, in Hyderabad, we have a multiple branches, right? And in Chennai, we have multiple branches. Similar way here, like in Delhi also, we have multiple branches. So now my all branches are connecting to here. If I goes this one branch down, only this one branch people will affect. But if my this core, my data center affects, then your whole branch is gone. So that's why at core and distribution layer, especially, even if you have any important device, at branches also you can configure the backup. But I'm saying these will have, must and should have the backup. If one goes down, it should work on another. So this is called high availability. HA we will call as a HA, high availability. High availability means even something goes down, my network, I don't want to disturb. Right?
Okay. Okay.
Okay. Any questions?